Hello everyone, this is DSA Zindabad. Today we are going to solve the seventh question of Arsh Goyal DSA sheet. And the question is chocolate distribution problem. Now let's look at the problem statement. Given an array A of positive integer of size n, where each value represents the number of chocolates in a packet, each packet can have a variable number of chocolates. There are m students. The task is to distribute chocolate packets among m students such that each student gets exactly one packet, right? The difference between maximum number of chocolates given to a student and minimum number of chocolates given to a student is minimum, right? Now let's look at the example. This is the example, right? Now let me write this thing for you. 3, 4, 1, 9, 56, 7, 9, and 12, right? So its output should be 6. Right, just because let's say we chose these packets 3, 4, 9, 7, 9, right? This one 3, 4, 9, 7, 9. Why we choose these number of packets? Just because it gives us the minimum. It gives us the minimum, right? Because like there are like multiple arrays which can be constructed from this input array, right? But in the question, it is mentioned like we need to find out the minimum number of chocolates given to a student is minimum, right? What does this mean? The difference between the maximum number of chocolates given to a student, and from there, the maximum number of chocolate given is 9, right? And the minimum number of chocolate given is 3, and its difference is 9 minus 3 equal to 6. So it should be minimum. And from this array, we can construct this array so that we can get our answer as 6, right? Now this is what the problem statement says. Like now we need to find out how can we achieve this, right? Now let's jump into the approach. Now let's jump into the approach. Let me make this array again. 3, 1, 4, 9, 56, 7, 9, 12, right? Now this question says we need to find out maximum and minimum, right? Whenever we see maximum and minimum in the question of arrays, what comes in our mind? Like sorting, right? And after sorting, we just need to traverse over the array following some condition, right? This is the basic approach, right? When I'm once again repeating, whenever we see maximum and minimum, we will try to sort the array and after this we'll just traverse over the array following some conditions, right? Now let's look at this array after we'll apply sorting. This will become 1, 3, 4, 7, 9, 9, 12, and 56, right? Now we have done this step of like sorting, right? This is after sorting. Now after sorting, we need to traverse over this array linearly following some condition. What do I mean by following some condition? Here m value is equal to 5. So how we can traverse over the array, keeping this thing in our mind, like we need to use space complexity to be big of 1. So what comes in our mind, like pointer approach, right? Pointer approach, right? Now we'll need like since the we need to find out like maximum and minimum from the array, so we'll need 2 pointers, right? We'll need 2 pointers, right? Initially, our first pointer will be pointing to the minimum element. Let's say its name is mini, and the second pointer will be pointing to the maximum element, right? And this will be this. Let's say like we need to construct our array of size 5, right? So that each and every student get the chocolate, right? This is the first condition we need to follow. This is our first array, right? This is our first array. Now after this, this is the maximum element and this is the minimum element, right? And the second pointer, which will be maxi, this will be pointing to the maximum element of the particular array, right? And after this, we'll need another variable to keep the difference between the maxi and the mini, right? This will be our answer, right? This will be our answer, right? Now, answer will store 9 minus 1 will be equal to 8, right? 9 minus 1 will be equal to 8. So our answer will store 8 initially. So after this, let's try to move our array. Now our array will be pointing to this and our mini will be pointing to this and our maxi will be pointing to this, because we need to find out the minimum from each and every array from the input array, right? That's why we keep traversing over the input array until we find the minimum, right? Now this will store 9 minus 3, which will be equal to 6. Now since 6 is less than 8, so our answer will be updated by 6, right? Now after this, again we'll increment our mini and as well as maxi. So now this time our array will be something like this, right? So 12 minus 4 will be equal to 8. Since 8 is less than that of 8 is greater than that of the 6, so it will not change our answer. So we'll again move our pointer mini as well as maxi, right? Now our array will be something like this. Now our array will be this, right? So now we need to see like 56 minus 7 will be equal to 49, which is greater than that of the answer, which is 6, right? So our answer will remain as it is 6. So we get this answer when we distribute the packets to be like this array, right? This array 3, 4, 7, 9, 9, right? 3, 4, 7, 9, 9, right? So 3, 4, 7, 9, 9. And from this, we get our answer to be 6. And in the example above, we can directly see like we can choose the packet to be 3, 4, 9, 7, 9, right? And we chose all of these packets, and from this, we get our answer to be 6, right? Now, I hope this approach is clear to all of you guys. Now, let's try to code this thing up. So, this is our question. So, first of all, we'll apply the sorting, right? Sort A dot begin and A dot end, and we'll initialize our 2 pointers. First one will be pointing to the initial start of the array, and the second pointer will be maxi, which will be pointing to the maximum element, which will be m minus 1, since we assume zero base indexing, right? And the third variable will store our answer, which is the subtraction of maximum and minimum, right? Now we'll run our loop from 1 till n minus m plus 1 till the last element of the maximum, right? I plus plus. Now mini will be equal to a of I and our maxi will be equal to a of m plus I minus 1, right? This is for referring to the last element, which is the maximum element of a particular array from the input array, right? Now our answer will be equal to minimum of answer and maxi minus min, right? And at the end of this, we'll return our answer. Now let's try to compile this. It compiled perfectly, compilation completed. Now let's try to submit this thing up. Yeah, this code runs perfectly fine. Now let's try to discuss the time and space complexity for the same. So here we are. Since we apply sorting, and for sorting we require big of n log n, right? And for this we'll require big of 1 since we are just creating two pointer and the one variable, right? And for this we'll require big of n. Now ultimately our time complexity would boil down to big of n log n plus big of n, which will ultimately equal to big of n log n, right? And the space complexity would be big of 1 since we are not using any extra space, no extra space, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share, subscribe, and comment if you have any doubt. Thank you so much.